Here comes the most important concept of the modeling design, that is the concept of design intents and design idea. Let's look at some rules on dimensioning. We just learned this as the first part of this course in traditional engineering. Do not dimension independent element. Why? What is independent element? In this drawing, what is independent element? This tangent line is independent. Okay. And for symmetrical features, we dimension the symmetrical whole over the size. We do not dimension half of it. For identical holes, we just dimension once and use the number times the size, like the 2 times 5, 5. That means 2 holes at the same size. And for arc, like for this arc, the length of the arc is very short, but we do not take it as make the radius. We take this arc and this arc are arcs on one big hole, one big circle, and we make the dimension as diameter, not radius. And for the overall size, like for this one, we do not dimension the overall size in this direction. Why? What do you think about this rule? Somebody think it's reasonable, and somebody think it's all nonsense. What do you think? Why it is reasonable?
Because by getting the independent dimension, you won't get the exact dimension. So you can take out the symmetrical 2 holes to get the exact.
Okay. Why it is reasonable? We should understand this from the view of design intents. That is, which is independent, which is dependent on the others. Of course, we should dimension the elements which is our intents. Like let's look at this picture. Our design intents is we make 3 holes. 3 circles. In the center is a very big circle, and 2 smaller ones symmetrically at 2 ends. So the size of this and this should always be same. We shouldn't, in this case, we shouldn't make the radius we shouldn't make the radius with a radius 5. Also, another radius 5. If we make another radius of 5, that means what? These 2 circles may be different. The size may be different. But if we just make one, that reflects the design intents. These all 2 circles always be same. Okay, and we use 4 lines to tangent with all these circles, and the size of these lines are dependent on the 3 circles. So we shouldn't dimension this. And in the real design, the shape, maybe we define the shape at the first step. We do not need to change it. But the size, after we need to adjust the size, like to fit, to match with the other part. If we adjust the size, the shape of the profile, the shape of our part shouldn't be changed accordingly. I mean the shape, not the size. But if we change the central distance, of course, the length of the tangent line should change accordingly. That is not we change the length of the tangent line and so the central point change accordingly. That is which one depends on what. So we just dimension the direct size, not the independent, not the dependent elements. And the symmetrical feature, that means these two holes always, these two circles always symmetrical about the central line. And the identical element, like this radius and this radius, always be same. So we only make one dimension, that means another meaning is these two always exactly the same. And for these two holes, we only dimension 1 with a number of it, that means these two holes always exactly the same. When we make in equipment drawing, we just make two circles identical. But in parametric design, we make one circle, another circle, we add a constraint, equal constraint between these two circles. That these two circles always exactly same in size. Okay, so that's why, based from the view of design concept, the rules on dimension are very reasonable. Actually, the design concept already exists in traditional engineering drawing, but it is not emphasized, and you cannot see it in the textbook.